Perfect. And we are waiting for Neeloy to join, but before Neeloy joins, I wanted to introduce our guest from Lambda, John Blaas. So John Blaas is a HPC operations manager at Lambda and previously worked at Argonne National Laboratory and the National Center for Atmospheric Research. He has more than 14 years of experience in designing and managing computational clusters, as well as providing tools and training in system administrators, user support, and end users. John serves as the vice chair of ACM, SIG PC, and SysPros chapter, and serves on the CARCC Systems Facing Track Steering Committee. Welcome, John.
Thank you, Boone. Glad to be here.
Thanks. And John, can you, while we're waiting for Neeloy, maybe just tell us a little bit more about, for those of that don't know, about ACM, SIG HPC, and SysPros chapters. Can you maybe tell us a little more about that and your background with that?
Yeah, of course. These are two very similar groups that we've managed to start to, kind of draw some overlaps between. And so for the past maybe almost 10 years now, ACM SIG HP SysPros has been putting on birds of feather sessions and workshops at SC and PERC. And so, for the past few years, I've been at least involved or leading some of those workshops at some of those academic conferences. And so, SIG HP SysPros, we founded it with the principle that, at a lot of these smaller computational sites, especially academic sites, most of the time, you'll only have, one, maybe two systems engineers that are working on these large, complicated computational resources. And so our goal with the group was to start to bring in people from all over the US and also the world to, give them a place to, kind of vent their frustrations or maybe ask a question out to the group, that they may not have an answer for, but maybe someone else in the group does have that answer or has been down that dark path before.
Sure.
And so it's a really great resource for a lot of these smaller resource center engineers to be able to share, their findings and get some context from other folks that may work at larger centers that do have a team and may have, already been down that path before. The same thing is with, CARC Systems Facing Group. CARC stands for Campus Advanced Research Computing Consortium. And the systems facing track is just one of many tracks that's attached to CARC. And so you can find tracks that also track data movement, how to, work with students or developing a student workforce. And so there's a great amount of knowledge transfer that's happening with CARC, and especially with systems facing track.
Awesome. And John, it's great to hear, people that are doing, things not just in a professional capacity, but in a personal capacity as well. So that is an awesome thing to hear about. And apologies to the audience. Neeloy from our side is having a few technical difficulties, but don't want to delay anything. I am just curious, Neeloy may cover this a little bit more when he joins, but John, from your perspective, obviously, VAST works with Lambda in a few different capacities. From your perspective, how have you worked with VAST at Lambda?
So it's kind of embarrassing, but I haven't worked with VAST up until I joined Lambda. And so, coming from a traditional pure HPC background, the primary file systems that we've had employed with our large scale computing systems has been traditionally, GPFS or Lustre, kind of the, what you would usually assume would be running on some of these clusters. But since joining Lambda, I've found a new appreciation for the VAST product and the storage platform that you guys put together. It's extremely performant, especially for the kinds of workloads that we see in AI. In AI, you'll often, especially during training runs and doing kind of your data pipelining, you'll need to be working with tons and tons of small files, oftentimes not the same size as well. And so it makes it very hard on, traditional, HPC systems that rely on kind of a underlying disk setup as far as their hardware. And so that's the one thing that I've noticed with VAST is, having that byte addressable kind of storage space really alleviates a lot of those issues that you see with some of those traditional parallel file systems.
That's great to hear, John. And thank you for providing that detail. Um, Before we kind of go into the fireside chat section, I do have a poll that I wanted to share just to get a kind of a feeling from the audience about where they're at currently in their AI journey. And this may very well kind of lead where we go with the conversation. And just as a reminder to the audience, this is a live webinar and we want to keep this as interactive as possible. And so if you have questions that you're, thinking of like, as we go here, feel free, whether for John or for us on the VAST side, feel free to drop those in the Q&A and we'll get those answered right away. All right, so we're seeing some interesting answers coming in already. So this is not surprising at all. Actually, it's interesting. So I'll go ahead and end the poll and share the results out to everybody. So you guys should see. We were joking before this that we're probably going to see a lot in the middle two kind of answers, and there had to be a few contrarians that said, "What's AI?" I mean, I think that if you're on the webinar, you'll likely know what AI is. But it is good. It is also interesting to see that there are some folks that define themselves as AI native, which means that they're pretty deep into that path. John, any thoughts from your side about these results?
I mean, this isn't entirely surprising to me either, especially, in the HPC space. A lot of folks are starting to just dabble their feet in the water as far as AI and, what they could be, really enable with the usage of AI alongside their workflows.
And then we've got my colleague Neeloy here on the line here as well now. So thanks.
Guys, apologies for that.
No worries. And Neeloy, we covered a little bit of background about the VAST and Lambda use case and how John is working with VAST. But we can go ahead and take us into our fireside chat portion now.
Yeah, I was going to say, and I say, John, you actually brought up an interesting topic, right? So AI has pulled from a lot of HPC history. A lot of folks who are AI researchers and scientists have an HPC background. So let's kind of dive, and given your HPC background, let's kind of dive in right there, right? How have you seen the space change? How have you seen, especially on the HPC side, folks start to change what they're doing, how they're looking at problems based on the emergence of AI?
Yeah, so I think that really comes down to, especially on the HPC side, the adoption of using GPU hardware resources in more of a computational capacity. For the longest time, in HPC, you really only use GPUs to do visualization of data. And, that was great, but in the last few years, we've seen really a surge in how much GPU resources are being put into some of these large scale systems. And so these large scale systems that would traditionally be what we call big iron or CPU centric are now integrating larger and larger contingents of GPUs. And they're really a lot of the researchers are starting to harness the power of these GPUs by porting a lot of their either some portions of their code that are very very performant on GPUs, but also being able to just full scale use those GPUs and do complete rewrites of their code. I think that's been a fantastic development.
Yeah, no, especially now you do a lot with the open source community, right? SIG HPC and things like that. Are you
Mm.
seeing sort of a difference in the way they're approaching problems as well, or maybe even the problems that are making it onto their table?
Uh, I think they're being cautious about the problems that they choose to start to port over. There's a large amount of work that goes into porting any kind of code, especially some of these ancient codes. You know, you'll see
Yeah,
codes still written in Fortran, and they're still being developed in those code bases. And so, you know, you do see some changes as far as, you know, starting to use Fortran with CUDA compilers and stuff like that. But also there's, you know, large scale rewrites that are happening in the community. I think the biggest issue, especially for like academic computing centers, especially the smaller ones, is just their ability to be able to get those GPU hardware resources, and you know, hardware resources that aren't, you know, already 3 or 4 years long in the tooth as far as the technology goes. And so I'm really excited to be a part of Lambda that can offer, you know, low cost GPU resources, especially to some of these smaller researchers.
yeah, no, especially and given the rate of change, right? Given the rate that, new algorithms make it from, academic concept into production use cases and being leveraged for real world discovery or analysis. I think it's having access to those resources, current GPU resources, becomes a big variable. All right, so let's kind of get into. I think Boone, we have one more poll question, right? We want to throw up. Kind of trying to understand where the audience is in regards to their role on AI.
Yeah. You guys should be seeing the poll pop up right now.
Perfect. Yeah, just trying to get a gauge of where people are as far as what you're involved in the day to day. See a heavy slant in the early responses towards infrastructure, architecture, and operations. We'll show the results here in just a second. Uh, you know, I think I think infrastructure folks probably have the most challenging job in when it comes to this space, because they're essentially, you heard John and I talk about all the uncertainty on the code level. Well, as an infrastructure person, you're essentially trying to prepare for all of that, right? And to best situate yourself for that. Um, so let's go ahead and start the results.
Yep.
Perfect. All right. Yes. Heavy on the infrastructure side. All right. So let's throw up the first slide. Get into a little bit of some of the work that VAST has been doing to essentially prepare infrastructure folks for the world of AI, right? And one of the big things that we've been doing has been to help operations and other teams understand sort of the entire end-to-end pipeline and flow, right? Because there's so much effort and thought put into access to GPUs, connectivity between GPUs, um, and all those things that are really model training centric. Whereas the bigger problem set goes well beyond model training, right? Data is what drives what the models are trained on, right? At the end of the day, the quality of the data and the way you prepare the data. And this is another thing that people don't necessarily understand, especially I think even more so on the academic side, is especially on the academic side, you were used to being given specific data sets, right? Here are the data sets we have access to. Here are the data sets we work with. Now let's see how we can analyze the data sets. When it comes to more enterprise AI, a lot more energy actually goes into the preparation of the data, because in that case, you're dealing mainly with corporate data, in some cases, third-party data, but you're really how you prepare that data and how you present that information in the model training process, and then even in the model serving and inference process becomes incredibly relevant, right? Not only could you, prepare bad preparation of data, put in information that shouldn't have been there in the model training or inference process, but also just the quality of the responses you get is very much driven by the input data. The other thing we try to train and educate, our customers on is the amount of data that you end up gathering from the model serving process itself. And this is especially important in terms of non-English models, right? Where the amount of source content is not as abundant as it is in English models. And so therefore, you are actually relying on the prompts to serve as additional training material to essentially, teach the model how do people speak a particular language, right? And so this ability to take the data from the inference side, use it to evaluate future models, use it to provide training data based on, let's say you're in a chat type scenario and a human interjects and provides some additional, this is what the right answer should look like, that type of data. So taking that model serving data and really feeding it back into the data preparation and model training steps to improve our models is an important part of AI going into production scenarios. So I think that's one of the important things. We talked about sort of the rate of change associated with the model, with the code, and the software stacks that are being employed, etc. And I think the other aspect to embrace is just the sheer volume and heavy movement of data that takes place in the AI world, right? In the AI training and inferencing workflows. John, any additional thoughts?
The one thing that I wanted to highlight is one of the better features of the VAST platform is the inherent data reduction you get from compression. So this is an easy win that saves a lot of time for these AI researchers. I know you mentioned in the HPC space there's some thought about how to actually present that data, compress that data. And so in the HPC space you often end up creating these sparse data sets that really benefit from compression. And so you'll see compression kind of workflows either surrounding like I'll use kind of the climate space as an example, NetCDF or HDF5 used as compression devices in order to realize some savings as far as storage space. And so I think having that as kind of baked in feature for the VAST platform is really powerful.
Yeah, there's a lot of one of the things that VAST focuses very much on is that data efficiency, and there's so many aspects to it: compression, hashing, and similarity based algorithms, a bunch of different areas. But yeah, absolutely. Especially this notion of tiering or archiving or cold data actually changes very much when it comes to AI, right? Because the data that you would think of as, oh, that's just historical archive, now actually becomes training material, right? That teaches models about image recognition or handwriting recognition or just even historical business patterns. And so yeah, having an ability to store that data efficiently is a big factor. All right, Boone, I think we got one more poll coming up here. So seeing as you guys are involved in AI, and especially from the infrastructure side, really curious to see where we're seeing this. What are you seeing as your challenges? What are people asking about? Even, it's funny when it comes to some areas, people once again obsess a lot about time to train a model, but are you getting feedback on, hey, how do I prepare my data better? And things like that, right? So give it a couple minutes here for some additional feedback. and I think we can share. And so there you go, data preparation and model training. So not at all surprising. And I think, tease us up really well for the next part of this conversation, John. So yeah, why don't we get right into it? Well, how has your world changed since engaging with VAST? And what are some of the things that you're seeing on your side, which I think will tie in very much to this poll that we have up here.
Yeah, so working with VAST has been highly rewarding. The support model around VAST is fantastic. Just having those Slack channels that connect us directly with VAST engineers has been fantastic and allows for quick asynchronous communications that really save us time. Currently, our biggest install for our one-click cluster deployment has been very performant, and we have seen no issues in saturating the HDR and FinBand links that connect it to the rest of the cluster. So that has been really wild to see. I also really appreciate the ability for our engineers to be trained with the VAST platform and alongside the VAST engineers. It's been really helpful to take on some of that rack and stack configuration of the hardware and to fit our increasingly aggressive deadlines that we set in order to deliver performant hardware to our customers so that they can kickstart their AI workloads.
Yeah, no, I think one of the things that people don't recognize is the amount of energy that it takes to enable our partners. I think we come from, I think all of us who've been doing technology and IT for a while come from relatively mature ecosystems, right? You haven't had to teach someone, 20, 30 years ago, switching was new and certain types of servers were new and things like that. But for a while now, it's essentially just been incremental updates, right? Of, hey, here's a new feature that's in the product. AI is quite different. The workloads are different. Even if you come from an HPC background and you have experience running, clusters and things like that, these enterprise-grade platforms are quite different from what you're used to. And so you're very glad to hear that you've been able to take advantage of some of the essentially, self-tuning, self-optimization capabilities that we have, which save you from, needing to tweak the underlying nerd knobs in the product and essentially just start consuming it and saturating pipes. So that's great feedback. Thank you.
Yeah.
All right. So questions you have for me? I feel like I've been asking all the questions, John. What are some of the questions you have for me?
So, talking about, different kinds of data types, what data types have you seen benefit the most from data reduction tools that VAST uses to maximize their storage on their appliances? And can you talk about any of your, biggest success stories that you've had?
Yeah. So, specifically around data reduction, it's been interesting because look, as people who look at various types of files and things like that all the time, you end up with some preconceived notions, right? You think, oh, uncompressed is going to be better than compressed. You think, oh, text is going to compress better than video, and all of these different types of things. And I will tell you that the most eye-opening recognition for us has actually been in the data protection space, right? And the realization there, I think, has been that, because typically you assume that data protection data is already highly compressed and optimized and so on and so forth. But I think one of the things that we always are surprised by is the power of sort of the similarity-based algorithms that we use, right? Algorithms that can take seemingly unrelated data and find a lot of commonality amongst it, right? And so therefore, I think the most eye-opening use case for us has been actually in the data protection area, where we have been able to, achieve significant data reduction gains, right? We would have never thought that we were going to get another 2 to 1 or 2.5 to 1 on top of already seemingly compressed data. Yet that is some of the numbers that we've seen. And so, that's obviously been it's been a pleasant surprise, compared to just, what you would have traditionally thought as data that would have compressed or reduced. As far as successes, I think one of the stories that I like telling most often is people who recognize the more advanced capabilities of the platform and are pleasantly surprised by it themselves. And I'll give you a specific example. In the analytics world, Parquet is a common file format that is used to store, structured data in an object format, right, for data lakes and things like that. And one of our customers is a large travel booking company. They were using our platform to store Parquet files and store structured data and do analytics, things like that. And they soon realized that leveraging our structured table storage capability, what we call the VAST database, it actually allows them to become a lot more efficient in the way they interact with their data versus the way it would have been, in traditional Parquet files. So I think that when customers come to their own realizations about how they can use the platform to optimize, because it's one thing as a sales or a customer facing organization to pitch a customer on, hey, you could do this or you could do that. But I think once customers realize that I can use a lot of these capabilities and they really start exploiting those capabilities to take advantage of the to improve their work pipelines, I think that's a ton of fun, right? And so in the data prep space around AI, along with traditional sort of business intelligence type workloads, customers have had tremendous success leveraging the VAST database, which, on top of the very fast NFS and all the other things we have that help accelerate the AI workflow. I think that's a great win for us when we have those types of stories. All right. Do you want to go ahead and tell us a little bit about Lambda? We spend a lot of time talking about VAST. Why don't you take folks through what your offerings are?
Yeah, I'd love to. Currently, we have 3 main cloud offerings. One of those we just introduced just this past month. But starting from smallest up to the largest, we have our on-demand instances. And so on-demand instances are instances in which you can get on immediately. We have a whole selection of GPUs that you can choose from. But you can get anywhere from 1 to 8 of those GPUs at an hourly rate and get fast instant access to these GPU instances as long as they're available. There's no reservations required. And so it's great for kind of those small researchers that are just starting to try out, starting to train their models, starting to do that initial legwork. From there, we have our newest offering, one-click cluster. So this is for users that have already gone through likely the on-demand platform, but are seeking, larger amounts of GPU resources because they now have their model trained a little bit further and are able to take advantage of, larger amounts of GPU resources. And so one-click cluster is a product where you can put in a request for anywhere from 16 to 512 NVIDIA GPUs that are connected by NDR interconnect. And so you have that backbone of a InfiniBand network so that you can really supercharge your model training. We offer these reservations for these one-click clusters in increments from 1 to 8 weeks. and it's a great way to maybe augment your computing resources temporarily, or maybe try out our platform in advance of possibly putting in an order for a reserved cloud. So that brings me to our last offering, Reserve Cloud. So Reserve Cloud is kind of what my team really kind of focuses on. But these are what you would traditionally think of as HPC resources. So they're fully isolated to the customer. All the networking is fully isolated. But these can be computing clusters anywhere from 64 to 16,000 NVIDIA GPUs. And we really have been focused on deploying H100s. We're hoping to also debut some new GPU platforms in the coming months. But these reserve clouds can be requested for a lease term of anywhere from 1 to 3 years. Typically, the way it goes is from purchase order, it only takes about 90 days to stand up these clusters and deliver them over to the customer. But it's a really great way to keep your costs in check if you know that you're going to need sustained computing resources. So yeah, just going through this again, for our on-demand cloud, we have a whole slew of GPU resources that you can request, all the way down to some of the older RTX and V100 GPUs. You can request up to 8 GPU instances, and launching and terminating and restarting these instances are super easy from an easy to use web developer API. And for all these instances, it comes pre-installed with all the popular ML frameworks that we like to call our Lambda stack. And just touching on some of the capabilities again of one-click cluster. Each GPU is paired with a Quantum 2 InfiniBand interconnect, and so you're getting 400 gigabits a second with 3,200 gigabits a second node-to-node bandwidth between worker nodes. We also additionally provide a Ethernet network that provides 200 gigabits a second out to the internet, and we also include 22 terabytes of local NVMe storage per node, allowing you to get the data sets or the data that you're training against right on the node. We also offer the shared network file system that's provided by VAST that offers petabytes of storage on demand that is highly performant. And then we also offer CPU-only head nodes for shared services that customers may need to run. And then finally, just to talk about Reserve Cloud again, dedicated single tenant hosted clusters that we will often, allow customers to add on, other items such as, a shared parallel file system. Perhaps they have, if they do have shared parallel file system, we also offer the ability to have a separate storage InfiniBand network. But the long and short of it is it's built with the lowest GPU per hour rate of any cloud provider, and we really pride ourselves on providing the highest flops per dollar available in the world for workloads requiring distributed training across the entire cluster. We also offer on-site 24/7 support, 99% uptime, and optional managed Kubernetes offering for these reserve clouds.
You do want to emphasize that flops per dollar metric, right? Especially as new GPU types emerge and they become efficient and the efficiencies they drive, etc. Thinking about it in a flops per dollar versus price per hour per GPU it becomes very, very important. So very glad to see you guys are already talking to the market in that.
Perfect. Well, we have come to the Q&A portion of the webinar. If you do have any questions, feel free to hit the Q&A section. You should see a button at the bottom of your screen. We already do have a few questions that have come in. All right, for the first one, can you walk us through the technical reasons why read performance is generally much higher compared to write performance on VAST systems when compared to other traditional parallel file systems? Neeloy, maybe if you want to start with this one, and John, if you want to tack on anything.
Yeah, so I don't know why I put up my hand, by the way. I don't think I did. From architecture, yeah, I think one of the things you have to understand to answer that question is a little bit of the differences in the VAST architecture, right? So a parallel file system focuses on distributing the data across a set of nodes and then distributing the access to that data across those same nodes. The problem or the challenge when you do that is you have a lot of coordination that has to take place between those nodes to ensure that you're providing consistent data back to the users, right? Because files can change, files can update, and you have to essentially ensure that you're providing a consistent information back to the user. When it comes to VAST, VAST has an interesting architecture whereby we disaggregate or separate the compute layer from the data layer completely, right? So no data lives on our compute layer and no access happens directly from our data layer, right? So all of the access is handled by the compute layer. All of the data is stored persistently on the data layer. And the every compute node has access to all of the data nodes in parallel, all at the same time, right? There's no sequencing or coordination that has to take place for the compute nodes to access the data. The data compute nodes all have all of the data nodes mounted directly to them and have access to them. So what this means is when it comes to a read operation, we can essentially spread that read operation across a large number of compute nodes and interfaces with zero need for coordination between them because they're all accessing the exact same data. So, as long as we do a good job of spreading our data across our data nodes when we write them, we can deliver very, very significant read performance. And we've done a lot of things to improve write performance as well. But the read performance becomes very good because you're essentially able to throw all of your available horsepower at serving up those read operations, once again, without the need to coordinate between them as to who's doing what or who's delivered what.
Perfect. We had another question here. This one from Sherry, and I'm not sure if this one should go to Neeloy or Johnson. Maybe Neeloy, you direct me. But can we access you? Can we access your GPU instance privately from our own data center? This one's from Sherry.
Yeah, that'd be for John.
Yeah. What I will say is that's really dependent. And so it really depends on, how you're trying to initiate that private access to our data center. But it's something that I'm sure our sales team would love to go over with you and really get the specifics about what you're trying to accomplish, because we'd love to work with you on that.
Perfect. All right, another question here. What is the story around automation? Pardon me. What is the story around automation for multi-data center replication and movement policies based on around user workflows? Maybe Neeloy, if you want to start with this one.
Yeah, I'll start with it, but I'm very curious to see how service providers like Lambda are exposing these capabilities, right? Because it's one thing to have the capabilities in the product, and it's another thing to expose them and how end users consume them. So from a product standpoint, everything in our system is constructed around this notion of a view, right? So because we are multi-protocol, we allow you to do NFS mounts, SMB shares, as well as S3 buckets from the exact same data. So you have to have a name for what you call that chunk of data, and we call it a view. you then have the ability to define protected paths that are attached to that view, or that view is attached to. So you then can say, for that same view, I may have a replication path going from point A to point B because I need high availability. I may also have the need for to expose that view via global namespace, where multiple clusters can access that data, even though it's not being replicated to it. I may have a desire to take that view and present it, replicate it to an S3 bucket for backup and resiliency purposes. So you have the ability to take this single mount point, which already is exposed in multiple protocols, and then tie it to a protected path, which can have multiple characteristics for it. So the advantage is you move away from these traditional schemes where you have to think about, oh, am I doing one-to-many, or am I doing, one-to-one? Is it synchronized? Is it asynchronized? Those all turn into properties of a protected path, and you can have many different protected paths and many different patterns available, right? Now, once again, that's from an infrastructure standpoint where we enable our partners to do many different things. So John, maybe you talk about how you think about that in your world and how you implement and expose some of that to your customers.
Yeah, I mean, all the reasons that you've described about being able to have some form of global namespaces across vast installations is really important to us, because we want to offer that kind of capability to our users so that they don't have to worry about where their data is actually located. They can take advantage of computing resources in one region, but have their data stored in another. I think that's a really compelling argument for saying that we are kind of standing above the rest as far as trying to make that not an issue for our customers, especially since a lot of the time for a lot of our regions, GPU resources can be scarce. And so oftentimes you find yourself in a region where maybe your data isn't actually located, and not having to go through that whole process of pipelining that data over to another region and having to tack that whole time on to your current process for training your data is really powerful, I think.
No, very glad to hear that you guys are doing it. Always makes me cringe whenever there's a provider that's on VAST that says, oh, your data can't be made available anywhere else. And it's like, I get it, right? There's operational issues and things like that, but still, it is so critical. And it speaks to both, you talked about scarcity of GPU resources. That manifests itself in a couple of ways, right? So as people are doing more inference, you sometimes are going to have the need to preempt model training with inference, right? Because you want to keep an SLA to your end users. It also becomes an issue when even you're doing data preparation, right? Let's say you're training a model and it's not converging, or you're evaluating it and it's not giving you the results you want. You could essentially kick off data preparation tasks on the same data in parallel in a different location to try and develop sort of a different data set that you might inject into your training process to get, to see if that helps, right? So there's a lot of these types of scenarios. So very glad to hear that you guys are exposing that to your customers.
Perfect. Well, I think we're at the 46-minute mark, actually, so we're a little bit over. So I think that's all the time we have for questions. I did want to let folks know, if you didn't get your question answered today, or if you have further questions from this event, or just want to learn more about the VAST Data Platform, we do host bi-weekly live demos on Tuesdays and Thursdays. And we do these actually both in North America friendly timing and also Europe and Middle East friendly timing. And so if you if you scan this QR code, I should say, you can go in and select a date and join one of our upcoming bi-weekly live demos. So we invite you to do that. And thank you so much for everyone for joining, and for John from the Lambda side. Thank you, for being a great customer and for joining us this morning, and Neeloy as well for coming to moderate.
Yeah, no, thank you for your time, John. Really appreciate it and your partnership. And thank you everybody who stuck around and listened to us. So hope you learned something. Thank you all.